Okay, welcome everyone. Welcome to DataEDGE 2022, hosted by UC Berkeley School of Information. I'm Jonathan Starr. I'm going to be one of your hosts today. Joining us later, we'll also have Mike Rivera, who will be the host on our Track 2 stage. We'll explain a little bit about how the tracks work a bit later on. So I'm really excited about today's event. We've got some amazing speakers, some great presentations coming up in the program. I hosted DataEDGE for a number of years, several years pre-COVID, in person on campus at UC Berkeley. So I'm really delighted to see that the program is back, and I'm looking forward to, probably not in the not too distant future, maybe to see us gathering in person again at some point. But obviously today we're going to be doing this virtually, and so a few things to note in this virtual space. We'll be using the stage chat feature all of today. That's going to be the way in which we mostly kind of communicate and engage with our speakers. We're looking for you to ask questions throughout this program, so that the stage chat feature will be the way to do that. I'd like you to get familiar, actually a lot of you have already, by, if you can, just put something in the chat there, sharing where you're from, and then also if you want to put something in about what you're most looking forward to hearing about during the program today. So I know I've seen many comments come in about where people are joining from all over the country. That's fantastic. If you want to put something in about what you're looking forward to, please do as well. Just make yourself familiar with the stage chat feature. And if at any point you have any help issues, any technical difficulties, if you click on the button on your left that's named Lounges, you'll find someone at the help desk there that's available and ready to help support those tech needs. So I think that's it in terms of logistics. Before we kick things off, we really want to first thank our sponsors, Wells Fargo, who are also hosting a recruiting lounge a little bit later on, and we'll provide you the details of that later on in the afternoon. I'd like to particularly introduce Shiraz Chakravarti, who's a School of Information alumni. Shiraz is the head of AI model development for enterprise functions at Wells. He's got over 20 years of experience leading digital transformation programs in retail advertising, acute care telemedicine, stroke consult settings, DoD, and then more recently he's worked in healthcare, medical insurance analytics, and data science consulting. In addition to all that work, Shiraz mentors future data science leaders as part of the school's mentoring program, and he's also a MIDS lecturer. He's been a really terrific advocate for as both an alumni of the program and for Wells Fargo. And I'm pleased to have him say a few words on behalf of Wells as we kick today's program off. So with that, I'll hand it over to Shiraz. Please, over to you, Shiraz.
Thank you so much, Jonathan. Awesome. So I just have a few things to say. First of all, it is truly an honor for us at Wells Fargo to be a partner and a collaborator with the DataEDGE conference and with UC Berkeley. Something that I wanted to mention today is that Wells Fargo has a very long and storied tradition when it comes to diversity, inclusion, data science practices. So, really, today we are gathered here to talk about some really inspirational research and insights from our peers within a really global community of practice, right? And for us, data science innovation continues to be informed by ideas of diversity, ideas of inclusivity. It is common sense. It is a must when it comes to research and new application in industry. So I'm thinking about a lot of themes when it comes to the talk today, but specifically the three things that come to mind is building solutions that are ethical, solutions that are explainable, right, and transparent. So that will be a theme all along. And we'll all hear and we'll discuss these themes today. A little bit of backstory, if I may. At Wells Fargo, we have many data science practice areas. But when it comes to these three themes, these are not just ideas, these are critical requirements of how we build our practice areas, how we build our models, how we test out methodologies and frameworks. So at every step, we're interested in making sure that we have a common understanding when it comes to the use of our data science products, and we want to make sure they're explainable. We want to make sure they're transparent and all that. So I'm really excited. We all are very excited and honored to welcome you all to DataEDGE 2022 for a conversation about not only challenges, but a lot of opportunities with the rise of big data. Thank you. Back to you, Jonathan.
All right, Shiraz, thanks so much for that. And we look forward to the recruiting lounge with Wells Fargo a little bit later on today. Now, as many of you who've been following the news, probably all of you have been following the news, the latest Twitter and Elon Musk news, we're sad to say that our keynote speaker, Ruman Chowdhury, is unable to join us given the sensitivities of the situation going on at Twitter. Ruman is deeply sorry about this. We at DataEDGE really have a lot of gratitude for Ruman's willingness to have initially planned to participate with us in our event. And we're obviously sad that she couldn't make it with us today. We completely understand, and we know that there are probably a lot bigger and more consequential things for her to handle at this time. And we wish her well with that. But we wouldn't obviously leave you all hanging. And so we're really excited to invite to the stage to provide the keynote here, UC Berkeley School of Information's head of school, Dr. Marty Hurst. Dr. Hurst is a professor in the School of Information here at UC Berkeley with a 0% appointment also in the computer science division. Her primary research interests are user interfaces for search engines, information visualization, natural language processing, and MOOCs. She wrote the first book on search user interfaces. Professor Hurst received her BA, MS, and PhD degrees in computer science from the University of California at Berkeley, and she was a member of the research staff at Xerox PARC back through 1994 to 97. Professor Hurst has received an NSF Career Award, an IBM Faculty Award, 2 Google Research Awards, an Arkawa Foundation Research Grant, and 4 Excellence in Teaching Awards. She's also an ACM Fellow. Please join me in giving a virtual warm welcome in the chat to Dr. Marty Hurst. And also, as Marty goes through her presentation here, please feel free to leave questions, because we do hope that we'll have time towards the end for a Q&A. And if you put questions in the chat, that will be fantastic, and we'll be able to get the interaction going from there. So please give a virtual warm welcome to Dr. Marty Hurst. Over to you, Marty.
Hello, thank you, Jonathan, for that introduction. Thank you, everyone, for coming. I'm very pleased to be here and to be able to welcome all of you to UC Berkeley Schools of Information's 9th Annual DataEDGE Conference. I'm first going to do opening remarks before I do this substitute keynote talk, just to get everybody situated here. While we've had to pivot to an online conference, we're pleased to again provide guests from industry, the nonprofit and governmental sectors, as well as UC Berkeley School of Information's Masters of Information Data Science, or MID students, an opportunity to learn from a network with data science researchers and practitioners. We have a terrific lineup of speakers today. As you heard from Jonathan, unfortunately, we just received word that due to developments at Twitter that you might have heard about in the news, our keynote speaker, Ruman Chowdhury, cannot be with us today. She sends her apologies at this last minute change. I will be giving a keynote talk, and hopefully it will be at least a decent substitute to replace her. In the past few years, unprecedented global events like the pandemic, climate change, and now a major conflict in Europe have taught us that one of the most important tools to combat these crises is the ability to gather and understand the information that surrounds them in order to provide solutions to these problems. An important way to develop and utilize these tools are highly skilled practitioners like many of you present today. Since launching the MIDS program in 2014, we have seen the need for data science professionals continue to grow, and we have seen truly remarkable students come through the program. We're also aware of the need for a more diverse community of data scientists. We're making some progress in the area of gender. In 2014, 20% of students in MIDS were women. Currently, the enrollment is 35%. We're working hard to attract women and candidates from underrepresented backgrounds as well to all of our programs, not just MIDS, but throughout the iSchool, and continue to create the conditions where they feel welcomed and supported. I'd like to thank our sponsor, Wells Fargo, for sticking with us as we had to skip a few years of the conference due to the pandemic, and they've generously sponsored us since 2018. This partnership over the years has been incredibly meaningful and has resulted in many talented iSchool alumni joining the Enterprise Analytics and Data Science division there, like Shiraz Chakravarti, who you just heard from. So now I will begin my keynote talk. If we could cue up the slides, please. Thank you very much. All right, so this talk is called Combining HCI and NLP to Get the Best from Both, where HCI stands for Human-Computer Interaction and NLP stands for Natural Language Processing. And I just realized that I think some of my slides have audio, so we'll see if that actually works in this talk. So what does HCI plus NLP mean? Well, in this talk, what I want to talk about is taking these two rather disparate fields and seeing what they have in common and what they don't have in common and how we can bring them together more than they have been in the past. So I'll talk about using natural language processing to help people within user interfaces and using human-computer interaction, which has to do with user interfaces, using techniques from that field or user experience, as some of you know it, using techniques from that field to improve natural language processing. And if you are familiar with either of these fields, you may be aware that the practitioners in these fields tend not to cross over very much. The conferences tend not to have a lot of people in common, but there is growing interest in the intersection. And in fact, this year at the North American ACL conference, the Conference for Computational Linguistics, they're having a special session emphasizing the combination of the two. So the interest is growing. So here's the outline of my talk. I'm going to very briefly outline the user-centered design process because I don't think everyone in the audience is familiar with it. So just a quick primer to that. Then I'm going to give 3 demos of recent research from my lab. And these demos demonstrate the combination of HCI and natural language processing. And then I'll give, at the end of each demo, I'm going to give some lessons we've extracted about the intersection of HCI plus NLP for each of these. So a quick overview of the user-centered design process. User interface design is an iterative process. It consists of what we call user research, which is interviewing users or observing users when they try to achieve their goals, then doing design, prototyping of interfaces, and this can be just sketching on paper or what we call low fidelity interfaces, then evaluating those designs and repeating the process many times. So it's an iterative process. We design, prototype, and evaluate, and then eventually build the interface. And then we continue to evaluate. And that's because user interface design is not it's a practice more than a science. The design space can be very large, and it's hard to know exactly where the right point in that space is to make a highly usable design. Although the more experience one has in user interface design, the more likely one is to start in a good part of the design space. Backwards. So user research is understanding who the users are, what their goals are, and what tasks they need to perform. And this includes something called task analysis, which involves characterizing what steps users need to take, creating scenarios of actual use, and deciding which users and tasks to support. This is a picture of a lo-fi sketch, or doing a low fidelity sketch, meaning showing something informal looking so that users or potential users are more willing to suggest changes than if you showed a polished interface, which people are less willing often to make suggested changes to. They're also easier to throw away than written code. So this is why we prototype. We want to experiment with many different alternative designs because our first pass is usually not the best. We want to fix problems before code is written because code is much harder to create than sketches and harder to change. And we want to keep the design centered on the user because once we write code, we're reluctant to change it based on what we're saying that users want. How do we evaluate user interfaces? We can use what are called discount techniques, which are very fast. So there's a misconception that it's very hard to evaluate a user interface, that it takes a long time, and that it's very expensive. Actually, by contrast, really a lot of user interface design is very fast. You have a paper prototype, you show it to a few people, you determine if it's in the right part of the space or not, and if it's not, you throw it away and redesign. We can also have expert user interface designers evaluate prototypes rather than showing it to participants, so that you don't actually even have to recruit in the early stages of user interface design. You don't have to recruit participants always. You can evaluate with participants. It's important that these are task and interface specific. So you do have to, when you get down to evaluating with participants, this requires a lot of care, thought, and iteration to get the design right. And in fact, I often spend more time on designing the formal evaluation than designing the interface, like really figuring out for a novel sort of evaluation. It can be very, it can take a lot of thought to get something just right. And I'm going to give some examples of these in this talk. So here, what I want to do is contrast the typical HCI process with the typical NLP process. In HCI, as I've said, we identify the user need, we develop a method to address it, and we evaluate the method on the user needs. Whereas in natural language processing, which is kind of like machine learning, we identify the natural language processing problem or the machine learning problem. We develop an algorithm and we evaluate the algorithm on these objective metrics like accuracy and speed. And you see here, we don't hear really a lot of talk about users. We sometimes cast the NLP problem as being something that people might want, like machine translation, say, but then we really have to focus down on what the technology needs. And so we see that these are not really exactly the same. They do involve identifying problems, developing something, and evaluating, but there's some important differences. And I think the two areas can benefit from each other's techniques. So to illustrate these, I'm going to give some demonstrations and, like I said, of recent work that we've done. So, whoops. So let's see. I believe there's some audio, and I haven't rehearsed this with the team, so we'll see if people can hear the audio or not. So this work was done with a large team of researchers at Berkeley and the Allen Institute of AI, and it was supported by the Alfred P. Sloan Foundation. So the motivation of this work was for people reading research papers. They can be quite technical, and if you've ever read a research paper, or even say a blog post about machine learning, I wonder if you've ever struggled to keep track of the notation or the acronyms when reading that paper. So if you see something like this, these terms are defined elsewhere in the paper, but it can be pretty hard to remember what they stand for. So like, what does Y stand for again? You know, sometimes it's hard to remember that. Or if you see a table like this and you're trying to assess the evaluation in the paper, it can be hard to remember what the acronyms stand for. Like, what does DNN stand for again? So we wanted to solve this problem and make it easier to read papers. So now I'm going to show the demo, and we'll see if people can hear. And maybe I can see in the chat if it's audible or not. Let's see.
In this talk, I introduce Scholarfy, an augmented reading interface that helps people read scientific papers by revealing definitions of technical terms and symbols right where readers most need them. The interface has extremely strong usability results, reducing the effort needed to answer questions about a paper. In a lab study, all participants reported they would use its core features frequently in future reading tools. The design of Scholarfy is motivated by the fact that, despite the importance of papers to scientific progress, they can be difficult to read. Comprehension is often hindered when the information a reader needs to understand a passage resides somewhere else, in another section or another paper. One problem is the abundance of abbreviations, mathematical symbols, and new terms defined within a paper for use only within that paper. These are called nonce words. Unlike standard scientific terminology, which an expert in the field is expected to learn and memorize, nonce words are like temporary variables in a programming language. They are defined for use only in the paper and can impose a memory burden for the reader to learn. They are often cryptic. It can be hard to infer a nonce word's meaning from context, and a paper can contain hundreds of them densely packed together. How can interfaces show definitions of nonce words to readers when and where they need them the most? We designed Scholarify, an augmented reading interface that surfaces just-in-time, position-sensitive definitions of nonce words, given a set of definitions that has been extracted from the text. At its most basic, Scholarify provides standard interactive hypertext affordances. Interactive terms are shown with subtle underlines to convey their interactivity without distracting from reading. Terms can be clicked to open compact tooltips containing definitions. Atop this basic interactivity, Scholarify provides 5 unique interface components to augment the reading experience. First, it improves on standard affordances for selecting terms to better accommodate definitions of mathematical notation. Any symbol can be selected by just clicking on it. Any subsymbol can be selected by clicking again. Second, it shows compact definitions of terms in tooltips. These definitions are position sensitive. That is, if the term has been defined differently in multiple passages, the most recent definition of that term is shown. Links accompany the definition, which take a reader to the definitions in context. And if a reader wants more information about the term, they can open a sidebar of all definitions defining formulas or usages of the term. The third innovation is called Declutter. When a reader selects a term, Scholarify eliminates visual clutter to help readers scan the paper for usages. It does this by highlighting segments of text that contain matches and fading out the unmatched sentences. The fourth innovation is equation diagrams. When the reader selects a display equation, Scholarify diagrams the equation, showing the definitions for all symbols at once, where labels are automatically affixed to each symbol and subsymbol in the equation. The final innovation is an automatically generated glossary of unique terms and symbols pre-appended to the start of the paper. This priming glossary can help prepare the reader for nonce words that appear in the paper. With these features, Scholarify makes it easy for readers to find out what a nonce word means without getting in their way. In a usability study, 27 researchers used Scholarify to read a scientific paper. When asked to answer questions about the paper with either a standard PDF reader or Scholarify, researchers answered questions correctly with both tools. When using Scholarify, they answered questions in significantly less time and found answers by looking at significantly less of the paper. They found it easier to answer the questions and were more confident in their answers. During unstructured reading time, researchers used all of the features of Scholarify to support their reading activity. Researchers reported they could see themselves using tooltips and equation diagrams often or always if integrated into their reading interfaces. Read our paper to learn about formative user research that motivates the design of augmented reading interfaces, algorithms for detecting and segmenting math notation, and evidence about the user experience of each of Scholarify's features.
All right, so that's the demo. Hopefully,
and stay tuned.
Sorry. Hopefully you were able to follow all of that. And so now, as I said, for each demo, I'm going to follow it by an HCI plus NLP tip with the elaboration below. So in this case, the tip is that usable interfaces require multiple rounds of pilot testing and refinement. So we did 4 rounds of piloting over several years to develop the Scholarify interface before being able to get these really outstanding usability results that we achieved. And it's very hard to get usability results like that on a very complex interface, like one for reading, a new interface for reading scholarly papers. In this case, the core idea of augmenting the formulas and equations with definitions and annotations of that kind was always positively responded to. But to get the details right was quite difficult, and we had to refine it for months with continual feedback from relevant users. We studied also, of course, the relevant HCI literature about hypertext, but a lot of those questions weren't answered until we did this refinement. Another important point that applies to pretty much all of the HCI design work that I do is that small details matter. Small details like the local organization of information on the page, visible cues for current and next choices, interactions that sustain flow from one choice to the next, making sure the text is legible without any artifacts, and following standards like what standards are expected in a PDF reader. All of these things have to be maintained. These are really constraints that have to be maintained simultaneously, or else the design will look cluttered and users will reject it. If you don't follow these HCI techniques, you get bad outcomes. And so here's an example from another paper that, some other papers that I took quotes from of other work where people did not follow this process. So here's an example, quote, "In a live system, presentational details became disproportionately important. In our initial deployment, rendered text contained artifacts of the underlying tokenization. These were no doubt relatively trivial matters of software engineering, but in initial informal evaluations, users kept mentioning these imperfections over and over again, distracting them from considering the underlying quality of the system." And this is from an AI group. So this doesn't surprise me at all. And people that are developing systems, they have a cool new feature they want everyone to use, and ignore these trivial details will have poor usability results when it comes to a design that's information heavy, like a reading interface. This is something I see over and over, but it doesn't get written up enough. So it's something I'm trying to emphasize to my fellow researchers so they don't make the same mistake. Another tip to take away is that real applications shed light on tough, underexplored natural language processing problems. So something that we still haven't completely succeeded at is automatic definition recognition, trying to automatically find the definitions for these symbols. It's far from solved and underexplored. And we've managed to improve the state of the art and get something much higher than the state of the art in this field, but it's really, really complicated. There's coordination problems, very complex syntactic structures that have to be understood. And even though there's a lot of talk of NLP being solved and amazing language models can do amazing things, they aren't even close to solving this problem, not even close. And it's solving the hard problems for real applications for real applications show what's solved and what's not solved, as opposed to flashy demos. So we had a lot of NLP challenges for this project. Document level definition detection is much harder than individual definitions. So for example, here we want to know that the hyperparameter alpha, that alpha is the nickname for hyperparameter is what alpha refers to. We want to be able to do term definitions, like textual entailment is the task of determining whether a hypothesis is true given a premise. Then we have things like acronym expansion, word sense disambiguation maps to WSD. But then we get these really complex ones here, like in a sentence with respectively, where we need to map D sub T to the L to top, and D to, I can't tell if this is an L or what, I think it's L to the left, and so on. So it's really very complicated. Just parsing the sentence is quite difficult, let alone doing the mapping. So we did develop the HEDX definition extraction system, which is the state of the art in this sort of problem. But as I said, it does not fully solve the problem. It's not accurate enough to really put in front of users at scale at this time. All right, so my second demo is the Word Zones project. And again, this is done with quite a few collaborators. And the idea here is to improve word cloud designs. So this is a word cloud, and word clouds are engaging, they're cool looking, they're fun. And they were originally intended for fun. And there's nothing wrong with fun. However, today they're used frequently, and I would say misused, in for more serious purposes, such as at the top for journalism, for, say, reporting what was in a State of the Union address, or in the bottom for scientific visualization, where they actually don't, in these two cases, these two don't actually make much sense. But they don't convey the intended message. So here we see this word cloud, and then the accompanying text for the news article was, Obama set out an agenda, turning back the effects of climate change, launching a moonshot to cure cancer, and a grassroots movement to demand changes in the political system. But if you look at the word cloud, these words don't appear in the word cloud, none of these words. So it's not really clear what role it's playing. And it's really hard to interpret a word cloud. So what is this a summary of? Give you a few moments. if word clouds are summaries, what is this a summary of? I mean, I think it's something about bears hibernating, but it's really Hamlet's famous to be or not to be soliloquy fed into the standard word cloud generator, but you couldn't tell. So why not? Well, it leaves out the stop words or the syntactic structure words, which have to be or not to be. And also it just takes a bunch of words, puts them in a bag, shakes them up and pours them out. And you don't really see the structure. So a lot of information is lost. So it's really not clear what it's showing you. What is this about? So it's kind of hard to tell. Is this a good way to show a summary of an upcoming course? So if on the iSchool website, this is how we put the courses instead of their names, would this be a good thing to do? Because this actually was an ad for a course. I don't think so. So our hypothesis is that, or was that standard word clouds are detrimental to understanding, and a list of words is better for summarizing a text. However, it's not as fun. So organizing the words both semantically and visually will improve understanding while retaining engagement. Because a list of words isn't that fun, so this is probably why word clouds appeared. So I'm wondering, can we split the difference between the engagingness and the informativeness? So we set out to find out if we could do this. So how could we fix this informational word cloud to actually make it informational? So I've got a simplified version of the original, which we then convert via this animation to this. So now we see it's kind of organized into groups of semantically related words, like words about probability and variance, words about P's and cycle and Mendel, so genetics, entropy, information model, receptor protein binding, function variable state, tests, exams, experiments, genes, and fluorescence in cells. So you could see now several topics here, right? Probability, entropy. You could see something about biology here and here, something about exams and classes, and about doing experiments. So you can see that buried in this word cloud, there were actually about 4 topics that this helps to pull out, while still making what we've shown experimentally people find to be an engaging layout. So we wanted to prove that this sort of thing is better. So how do we test this hypothesis? Well, the problem is that prior evaluations of word clouds were not done scientifically. There are no shared data sets, there's no reproducibility, often no human evaluation at all. People would just say this is a great design, often unfair baselines and only one baseline, and often the tasks examined did not match the underlying stated goals of the word clouds. So the task would be find the largest word, but if that's the goal of the word cloud, you might as well just have one big word and nothing else. So we came up with a new evaluation method that we want others to use for assessing word clouds. If the goal is to determine how well a layout summarizes the main topics of a document while retaining engagement, and if the goal is reproducible evaluation and an evaluation that reflects the task. Since many people who use word clouds say that they summarize the content of a document, we felt that this summarization or gisting task was a good one to assess according to. So our idea, after many months of thought, and this did not pop into our head, but what we ended up coming up with is a new way to evaluate something like word clouds based on the game of taboo. So what we do is we build up sets of words that unambiguously indicate a subject or a category, like Mendel's P's, like genetics. The categories simulate the topics of a document, and we see how long it takes for someone to guess the underlying categories when these words are arranged in different layouts for a word cloud-like design. So here's an example. Here's 5 words. What's the underlying concept? I hope you all thought restaurant. And we actually developed a set of lists of words like these, and we got 95% agreement or higher in isolation with native English speakers, meaning 95% of the time or more often, people said the same word, restaurant, when they saw these 5 words. This was very time consuming to construct, this stimuli set. It required many rounds of iteration until it finally worked. So then we have these sets of 5 words and we can lay them out. And now we can see, we can ask a question like, what are the underlying topics? If you look here, we've color coded, and hopefully you see too, something about college or university and cow. If you're a native English speaker from the US, if you're not, it might not be as obvious. And then what we were able to do is lay these out in groups of five groups of 5 words in different layouts and assess which ones allowed people to more quickly and accurately guess the underlying categories. So we would see how many categories can you name in the time limit. You can score from 0 to 5 correct. And we were able to then compare these different layouts based on this quantitative assessment. So we could compare. So first you start simple. When you do a visualization assessment, you want to strip everything out. So we just compared no color, single column, single font, column, single font, column, multi-font, and then the Wordle layout, single font, and the Wordle layout, multi-font, just to see if the font size mattered. And so you hold some aspects constant and compare others. And here we were able to find that the standard spatial layout, the word cloud Wordle layout, was far, far worse for accuracy than putting things in these column layout by a large margin. So the key findings were that visually grouped layouts compared to ungrouped layouts are more effective in time-constrained category understanding tasks. And the visual grouping can be achieved by separating categories via these blank space or color or both. And for analytical tasks, the layout with blank space tends to be preferred over spatially arranged groupings. And this was a big deal to us. We actually found that people preferred our layouts over the standard word cloud. So it was still engaging while being more informative. And these results hold only if these groups are semantically distinct. And so the hard part is that these still have to be manually determined because algorithms for automatically grouping words semantically still are lacking. So benefits of this evaluation approach are as follows. It's reproducible. It allows for fair comparisons across many baselines, and you can combine these sets of 5 words many different ways and compare them. It yields statistically significant results, and it measures some of the underlying goals of the design. We also compare it with subjective evaluations. So we can have objective and subjective evaluations. So what is the takeaway for NLP plus HCI here? Well, one is evaluate with realistic, relevant tasks, which hadn't been done with word clouds before. So you want to make sure the evaluation task matches the realistic use cases and observe both subjective and objective and quantitative results. And you want to compare against a realistic, strong baseline. This is something that HCI doesn't always do, and it's very prevalent in the NLP field. So we want to be sure that the contents are the same in both cases and vary as little as possible between the 2 designs to get really believable results. And do reproducible studies. And this is really a lesson that HCI can learn from NLP. It's not done nearly as much as is done in natural language processing. So this is a place where AI can really help improve HCI or user experience. My final demo is a news chatbot. And this is done really primarily by my PhD student, Philippe Laban, who's now at Salesforce. So the motivation was to provide an interface to news that inspires deeper engagement. So we were concerned that people weren't getting enough news or were just hearing the headlines. And so originally, we wanted to get people to engage in news and help journalists also write their stories. And our approach was to process millions of news articles, automatically detect stories, timelines, and entities from this text, and visualize these. So the results overall of this multi-year project was great NLP research in summarization, simplification of text, entity recognition, headline grouping, and a very highly valuable data set for NLP. The problem was that our very cool UI did not engage lay people or help journalists. So Philippe's original ideas for the interface just did not cut it. So here were some early ideas, and this is pretty typical when you have a lot of data and you just visualize it and you're saying, this will be really useful for people. So we had this amazing, the algorithm is really pretty amazing. It's really quite effective at pulling out the major topics completely automatically from the news. This is all automatically pulled out. This is from 2016 and automatically labeled what were the main topics. And then there's a timeline showing when there are a lot of articles about each of these topics. So pretty good if you're doing data analysis, but not so great for reading the news, it turns out. And then we got even more sophisticated doing a dot chart with automatically created timelines with titles pulled from the articles, automatically extracted people and from Wikidata and information about them, and really pretty darn cool what we could show over time. We could show stories that ranged over many years, including airline crash investigations and so on. We did a lot of variation on this interface. But in the end, it wasn't useful. It was only good for people that were really, really into the news, which was the opposite of our target demographic of people that were casual newsreader. So our new approach is the NewsLens chatbot, where again, the goal is to get casual newsreaders to engage more in depth. So here, the hypothesis is question asking will increase engagement. So here we want to bring NLP into the interface to get people more engaged with reading the news or consuming the news. So here I'm going to describe the chatbot demo. So we put it on a Android, or I guess it was an iPhone interface, and the news was organized into stories, as I showed you before, and each story was put into what we called a chat room. And example stories here are the Iran plane crash and the Boeing 737 MAX, and others you can see here, again, automatically created. A chat room starts with a timeline of events, and each event is composed of multiple news sources. And there's tabs to look at the different sources and so on. And questions are then automatically recommended to the reader by an NLP system, and they're updated as information is revealed. And information is gathered from news and Wikipedia sources for talking about individuals and other things. The reader can ask their own questions, and an extractive Q&A system tries to find an answer based on the reader's questions. So I'll show the demo video here.
In the chatbot, the news is organized into chat rooms. Let's look at the Boeing 737 story. Each room is initialized with a timeline. The user can click on recommended questions to navigate the story. For example, who replaced the CEO of Boeing? We use a Q&A model to answer the question. Users can also type their own questions. We keep track of the conversation state to recommend unanswered questions.
All right, so you get the point. So we did a study to see if this sort of design had caused more engagement with the news. And we found that when the chatbot recommended questions, the newsreaders tended to have longer conversations with it. And we have some more recent work that I guess was just presented actually at IUI with an audio podcast version that found that participants preferred a news podcast with Q&A versus one with stories read straight through. And in this case, we made a conversation automatically between different speakers, with different voices. So it was really like Today Show kind of thing, where one voice, say a male voice, would read part of the news and a female voice would ask questions and the male voice would answer. And then the user could then ask additional questions. So we found that this is a very promising way to engage people with the news. Of course, the question answering and asking isn't perfect, but that's very rapidly improving. And so it's probably going to be more effective in future years. So takeaways: real applications can yield highly valuable data sets for NLP research. And when Philippe started his work, he wasn't sure if he should work on this application area. And I said, no, you should, because it will really give you direction for what to focus your research on. And as I mentioned, he's developed state-of-the-art abstractive, unsupervised summarization techniques and text simplification techniques making use of this data. And beware of cool versus usable. So if you develop something, an interface, say, that looks cool, it really might not work as an interface for the intended users. Often it doesn't. And our first versions of Newslands were very cool looking, but were really not usable for most people. We really had to think about how do people want to consume the news? What's going to actually be useful for them? We also had to wait for the audio, speech recognition, all that to catch up. It was a few years too early, but it did improve enough for us to make a kind of a workable interface. Here's another example of somebody putting cool before usable and suffering the consequences. After spending a lot of effort on the cool NLP problem, the feedback we received from our users was quite sobering. Apparently, our users are a target audience with needs and preferences quite different from what computational linguists would prescribe. To summarize, the users opted for a more intuitive presentation style. So again, this is something that people find over and over. They don't usually write it up, but often the design fails because we put what we think is cool as researchers or as practitioners even ahead of what users really want. And so I have some details about the NLP method for keeping track of conversational state. I think I'm a little short on time, so I think I'm not going to say this in a lot of detail, except that very briefly, for a given story, we want to be sure there's not redundant content. So we start with all the paragraphs in a story, and we use a standard question generator to generate the questions, many questions for this story. Now we have a lot of paragraphs and a lot of questions. And so what we want to do is eliminate the redundant questions and the redundant paragraphs. So we make a bipartite graph like this, and we say 2 paragraphs are redundant if they cover the same questions. So once a question is asked, we want to remove, so say we ask this question, it's covered by this paragraph. We want to remove these other questions so that we don't, and the paragraph, so we don't keep asking the same questions. That's kind of the basic idea. And I'm not going to go into this. I'm definitely going to roll out. This is our summarization algorithm. It's pretty detailed and it's quite technical. So I'm not going to talk about these things. And this is our text simplification algorithm, but in the interest of time, I'm not going to go into that in detail. I will say, well, maybe I'll give an example of text simplification. So what is text simplification? It's rerunning text targeting a certain level of readability. So this would be a paragraph at college level, 10th grade level, and 6th grade level, written by humans. And something you might notice is that it gets longer as it gets simpler because there's more helper words, and sometimes more sophisticated words are good summaries. So you need to expand those out. Our algorithm uses reinforcement learning and other state-of-the-art NLP methods to do text simplification. But what I want to talk about is the novel evaluation that we used for assessing this. So what we did was we took the original document that's not simplified, a handwritten simplification, and some competing algorithms, including ours, and we assessed it by actually seeing which of these best answered questions about the documents. Because if it's simplified away too much, it would no longer be able to answer the questions. And so that's how we did the evaluation. And so we were able to see if the simplified document could answer the same questions. So here's an original document and a simplified version, automatically simplified by our algorithm. The original is, each summer, libraries in St. Louis, Missouri host many types of free camps. yoga, chess, and even a Harry Potter sorting hat camp. In 2020, Camp Dreams seemed far-fetched given the global coronavirus pandemic. That didn't stop St. Louis libraries, though. And here's the automatically simplified one, 2 levels simpler. In the summer months, St. Louis has many free classes for kids, including yoga, chess, and a Harry Potter sorting hat camp. In 2020, Camp Dreams again seemed far-fetched given the crisis. That didn't stop St. Louis libraries, though. So you can see it is simpler in structure and vocabulary. All right. So I'm out of time here. So in summary, we want to combine HCI and NLP. We want to use NLP to help people with user interfaces, as I've shown, for text simplification, for making news more accessible, for better word clouds. And we want to use HCI techniques to improve NLP, to help us decide what sort of NLP should we do. In the Scholarify example of making it easier to read text, this should direct us to what sort of NLP problems should we try to solve, really finding definitions versus maybe writing funny text automatically. So how to come up with a successful novel user interface design. Be sure you've identified a real need, put user needs ahead of technology coolness, pilot your design. Small details matter as much as large ideas. And don't assess what makes one's own technology look good versus assessing what people need or understand. Don't just measure what's easy to measure versus what matters. Spend a lot of time thinking about your evaluation and pilot test that evaluation. That's very important. Your first pass isn't necessarily going to work, and get it right. So thank you very much for your attention. And I'm very happy to take some questions in the remaining time that we have, if anyone has any. And I don't know how I can see the questions or hear them, so hopefully someone will tell me. Oh, I see it in front of me here. Okay, good. How do users understanding with NewsLens compared to something like a Reddit thread? And there's user-user conversation. Oh, that's really interesting. Well, I think that there's probably no substitute for human-human conversation directly. But if you have, I guess the difference would be with NewsLens, it can look up the information automatically online. So it can look at a lot of resources and pull out answers to questions like, who is so-and-so? What's the ramification of this and that? And really be more about the news, whereas somebody talking to someone else in a Reddit thread might not have that information. But, it's sort of an expertise question. But I think people talking to each other is probably always going to be better than talking to a computer. Does the thing have a plugin as if we're referring to the NewsLens? So other knowledge sources can be brought in? No?
No, it's referring back. Marty, it's referring back to your initial, the Scholarify application.
Yes. Scholarfy at AI2, there's something called Semantic Scholar now, and it is a semantic reader. And we are diligently working on, in fact, I think we released an open source version of the software to make your own reader tools. And we really want people to build on it. We had there was a version of it that was based on our research software, and they have re-engineered it, and they've made more of a product version that has just been released or is close to being released. The part where it recognizes the formulas is not in there because that's still really hard to get right. You get it from the PDFs and so on, but it does hyperlink a lot of the other information, and we really want everybody, lots of people to build on that. Yeah.
Great. And just a couple of follow-up questions on the Scholarify, simply because there were a lot of questions, real lot of interest in that, Marty, was the question of how is scalability handled, let's say, for new symbols? Are there kind of limitations on the symbols? Was one question, and then maybe one other one that you might want to talk a little bit about is what training data was used to solve for some of these. So one about scalability, and then maybe one about training data, and we'll leave it there.
Sure. No, well, the symbol recognition, I have to say, it's just still not solved, in part because we really wanted to make it work on PDFs, which is what people read. Doing it on HTML would have been so much easier, but except for some of the formulas in HTML are still images, so that it wouldn't solve that problem. It's this number of symbols is somewhat limited, but their meanings are the number of meanings for symbols is sort of limited, but the hard part is really recognizing the groupings with the structure, with the superscripts, subscripts, which we did do, but still there were errors. So we haven't been able to make that scale to the degree of accuracy is necessary to put it up in front of many people. So unfortunately, that part is not in the live system, much to my great sadness, but I still hope that someday it will be there. We just still need people working more on that part. So it's still just a demo, the part with the symbols, but the other parts of it are up there at Semantic Reader.
Okay, great. And anything, there was one other question from Renelle around what training data was used to solve?
We had to do our own. We had to label it, and we did many rounds, and it's really getting agreement on definitions. It's actually not a solved problem. The few data sets that are out there, they're really inconsistent, they're small. Just what is a definition for a term, a written term, let alone a symbol, is extremely hard to define. We did, again, I'm somebody who's done a lot of getting regularity in evaluations, as I described for an hour, and getting agreement on the code book for definitions. We never really fully succeeded. I haven't seen success in that. So it was even harder than we expected. So we did a lot of our own annotation. We got a little bit of crowdsourced annotation. We have some data sets, but we haven't really released them because I have to say they're not up to the standards that I expect of a releasable set of annotation guidelines. The inter-annotator agreement just is never high enough.
Okay. Dr. Hurst, thanks so much, and thanks for bringing such great examples into the important conversation there. And listen, thank you for stepping in very much at the last minute, obviously with the changes that we've had. But please, everyone in the chat, please show your appreciation for Dr. Hurst and the keynote this afternoon. Thank you so much, Dr. Hurst.
My pleasure. I always say a professor can talk on any subject for any length of time at any time.
There you go. Wonderful. All right. Thanks, everyone. For the remainder of our session today, we'll now be moving into two different tracks or two different stages. And you'll see in your interface, there's going to be a browser in Hopin where you're going to be able to select two different stages to continue attending today's event. You'll see that we've got a number of speakers on track 1, a number of speakers on track 2, and you can hop between them according to what you're looking for. So if you'd like to listen in a moment or two to Esther Yu's talk on artificial intelligence for medical imaging, you stay on track 1. You'd like to attend Samir's talk on quantifying vision through language demonstration, that'll be in track 2. So that's the way in which we're gonna play the next part of this. So if you want to see an overview of the schedule, you can visit the event's homepage, look at the agenda, and then you'll be able to kind of see and create your own agenda from that. If you have any questions, obviously throughout this, please continue to use the comment section, continue to use the stage chat. That's been great. Very, very good to see all the questions coming in and all the comments. Please keep those going as we go through the afternoon. So with that, I will see you on track 1. Mike Rivera will be joining you as a host on track 2, and we'll see you in tracks just momentarily, and then we'll get going with the rest of our program this afternoon. Thanks, everyone.